Alright, let's talk about solving quadratic equations by factoring. So what we're going to do is we're going to factor both of these quadratics, and then we're going to use something called the zero product property to solve them. Alright, so I'm going to show you my way of factoring. It's a little different than maybe you've seen or learned already so far, but I think my little special way could be very useful, and try it if you want. If you don't like it, use your way of factoring, but still you're going to apply something called the zero product property in solving it. So here we go. All right, here's my way of factoring. We use something known as the diamond, even though you'll see kind of why it's called the diamond here. What you do is you take the -6 here, you make a little x, or you could call it a diamond if you want. This is why I call it a diamond. You don't have to put the whole diamond around it. And you put the -6 on top, and you put the -5 on bottom. Okay, now what we do is we're thinking of two things. We're trying to think of two numbers that multiply to get the top and add to get the bottom. So again, we're trying to think of two things that multiply to get -6 and add to get -5. All right, so if you think, okay, what would work there? That would be, well, it looks like -6 and 1. And then what you do is you go, okay, -6 and 1, so here's how you factor it. You basically, because it has an x, you put x, and then you put the -6, and then you have x, and that's a +1, equals 0. So again, you just take this, put it on top, put that, put it on the bottom. Two numbers that multiply to get the top, add to get the bottom, and those two pieces are inside the factor. And then what you do is, to solve it, we factored it. Now to solve using factoring, what we do is we use something called the zero product property. Let's talk about that. It says if the product of multiple terms equals 0, then one of the terms must equal 0. Now here's what that says. It's kind of confusing when you read things like that. Sometimes you go, what? Show me what you're talking about. So here we go. I want to know what would make this 0. Well, wouldn't this or this, one of these has to be 0. So when you multiply, you get 0. Think about it. Can you ever multiply two things and get 0 if one of them's not 0? One of the two has to be 0 to get a result of 0. That's what this statement is saying. So wouldn't x minus 6 has to equal 0, or wouldn't x plus 1 have to equal 0? Don't one of those two have to equal 0? Now you could probably look at this and go, oh, that's 6. Yeah, because if you just add the 6 over, you get x equals 6. And here you could probably say, oh, -1 will make that 0, because you're minusing 1 over, and you get -1. These are your two solutions. You solved this quadratic. There are two solutions. And you did it by factoring. Now if you went back and plugged it in, 6, if you plugged in 6 right here, the thing would equal 0. If you plug in -1, the thing would equal 0. If you look at the factored form, when you plug in 6, wouldn't that create 0 times 7? When you plug in -1, wouldn't it be -7 times 0? Give you 0. So factored form helps you solve using the zero product property. And hopefully this little diamond's kind of nice. Now I'm going to use the diamond again for this one. Now there is no GCF, meaning greatest common factor, so I'm going to use the diamond once again. Except for in this one, since there's a number in front, you actually have to multiply by the -12. Here, there was no number in front, so you didn't have to worry about multiplying, but now I multiply the 2 times the -12, and I'm going to get -24. Okay, you don't have to make the whole diamond, I usually just put an X. The -5, the middle one, is still on the bottom. So again, you multiply these two. Now same thing, you're trying to find something that multiplies to get the top and adds to get the bottom. So what would two numbers be that multiply to get -24 and add to get -5? That seems like it would be -8 and 3. So we have x minus 8. Remember, you take this, and we have x plus 3. Take that. Remember, equals 0. We're just factoring the left side. But there's one oddball thing that happens here. Because I multiply this 2 times the -12, I have to divide that 2 back off. It's kind of weird, but it's really slick, and it works. And all my students love this method. It just works for them. So I take that 2, because I multiplied it in, I'm now dividing it off, these two. And here's what happens. What is 8 divided by 2? or I should say negative 8 divided by 2. Isn't that negative 4 when I reduce it? Does this reduce? No, 3 over 2 doesn't reduce. Now, if it did reduce the fraction. But since it doesn't reduce, since there's still a denominator, what you do is you take this denominator and you move it up. And that would become 2x plus 3. Again, this is kind of weird, but you reduce each fraction if you can. Always reduce. And then if there's any denominator left, you move it up. This one did not have a denominator, so nothing moved up. This one does have a denominator. It goes up. And there's your two terms. And this is the factored form. It's really slick. Hopefully it kind of makes some sense. Give it a shot. You might like it. And then what I do, just like before, with the zero product property, I set each factor equal to 0 and solve. Because for this to equal 0, either this equals 0 or this equals 0. Now, this one, hopefully you can just add the 4 over, or you can look at it and go, what minus 4 gives me 0? Hopefully this one you can see that 4 is the answer. For this one, it might be a little bit harder to see the answer is negative 3 over 2. So what I do is I would probably completely solve this one. So minus the 3x over. 2x equals negative 3. And then I would divide by 2. And I now have x equals negative 3 over 2. So those are my answers to this one. And if you look over here, those are my answers to this one. If you decided to put these in, you would see these would come out to be true for this and for this. Both of these create, sorry, and for this right here. You create for, because this is in between. If you plug these answers in here, you get 0. If you plug these answers in here, you get 0. And again, this diamond thing, do it if you like. If you don't, use your normal factoring methods. Remember, this number goes on top, this goes on bottom. Two numbers that multiply to get top, add to get bottom. Here, you multiply these two first, do the diamond, and then divide off that number you multiplied in, and then reduce and bring it up front. Slick ways of solving factoring is very useful. Whenever you solve quadratic, factoring is one of your best bets. Later on, you're going to learn some other ways of solving quadratics. One of them is called the quadratic formula, and there are quite a few other ways too. Good luck in your journey with mathematics.